So day 9, as of today, we're taking a look at how you event this mentally. And again, I'll put up some numbers there and you'll take a look at it. So first thing we're going to do today is take a look at a couple situations. So a large cake is in a room. The first person who comes in takes 1/3 of the cake, then the second person takes 1/3, and the third person takes 1/3. Is there still cake left after 3 people eat the cake? What do you think there? Well, let's see. So if there takes 1/3 of the cake, so how much is left would be 2/3. Now this next person, let's see, they take 1/3 of what is left. So this person, they take 2/3 and they take 1/3 of that. So that's 2/9. So we got to figure out, what is this? Let's see. Well, that is, or I like to think about it. Actually, let's think about it. If there's 2/3 of the cake left, how much is left if somebody takes 2/3? Would be another 2/3 is left. So that's 4/9. And then 2/3 of it would be left if somebody came in and took that. So that's 8/27 times 2/3. So that's 1681. So it keeps getting smaller and smaller. Now we're asked to write 2 definitions, one recursive and one explicit. So our recursive would be, we start with 1, and what's left is 2/3 times the previous. Now our explicit, we could say we start with 1, then we keep multiplying by 2/3, n minus 1 times. What is a reasonable domain? Well, how long do you think we can keep that cake going for? All right, so the pattern above represents squares where Wn is the number of white circles. Write a description. Well, so we start with 4, 1, 2, 3, 4, and then 7, 4, 5, 6, 7, 8, 9, 10. So I'm going to say we're going up by 3. So our recursive, we start with 3, and then we take our previous and we're adding 3, except I should say we're starting with 4. So what's our 0 term here? Our step 0 would be 1. So our explicit is we start with 1 and we add 3 each time. So a domain, well, how big do you think the tables could be? Well, it depends upon the space, so how many you might have there.